It's time for Arrested DevOps, the podcast that helps you achieve understanding, develop good practices, and operate your team and organization for maximum DevOps awesomeness. I'm Bridget Kremhout with a great show for you today. But first, a word from our sponsors. Okay, so I feel like I have to start this with the movie announcer voice. In a world where Kubernetes meets microservices, what's a developer to do? Here to address this exciting service mesh world, we have two guests. So how about you tell us a little bit about yourself, where you live, where you work, what's the smallest change worth opening a pull request for? Starting with Michelle.
Hey, Bridget, thanks for having us today. My name is Michelle Noorali. I live and work in Atlanta. I'm a software engineer here at Microsoft, and I work primarily on open source cloud native technologies. So I was a core maintainer on projects like Helm, Draft, CNAB, and now I focus primarily on the service mesh space. So with projects like Service Mesh Interface, SMI, and now OSM, which we'll talk about open service mesh a little bit later. So smallest change worth opening a pull request for. So I generally misspell things all the time. So I think the smallest change that I appreciate is like a docs change or a spelling fix, grammar fix. So I always try to open those as well in other people's repos because I know I appreciate when people fix my mistakes. So I think that's what I would go with.
That's actually awesome. I agree. I think some of the pull requests that I was the most excited about recently was pull requests in Helm where people were putting in new lines just to disambiguate something in the docs. And I was like, that's so helpful. Thank you. They're like, I know this is small. And you're like, no, this is good. This is good. Oh, all right. So I love it. So Delyan, tell us about yourself.
Well, hi friends. My name is Delyan, and I live and work in the San Francisco Bay Area with Michelle and Bridget. And I'm also a software engineer at Microsoft. And for the past year and a half, I've been focusing on various reverse proxies, Microsoft Azure's App Gateway, and Kubernetes, trying to bridge the gap between Ingress, Kubernetes, and now Service Mesh. Extremely exciting and overlapping fields. Smallest PR, I also appreciate typos or correctness of comments. I love adding comments to clarify things. And surprisingly, it's so easy to actually make tiny little PRs via the GitHub UI. You can actually edit code via GitHub UI. I love that. Sometimes reading code. I love reading code actually. And I like to tweak comments to clarify as well. Favorite pastime.
That is actually awesome because imagine comments are like a gift to your future self, a gift to yourself at 2 a.m, a gift to future members of your team when you've rolled off the project and they're like, oh, this is why Delyan did this. It's like, don't tell me what's in the code, in the comment, right? Like I can read code. I want to know what you were thinking. What were you thinking?
Yeah, I should have said, I also love leaving to-dos. Sometimes I would just open up a little editor and say, to do, we have to add XYZ here. I'm fascinated by to-do driven development.
Oh my gosh, I love it. To-do driven development. All right, love it. So our agenda for today is service mesh. And we've done in the past, not we, the people on this podcast, but we, the podcast, have done a number of Arrested DevOps episodes about Kubernetes, because buzzword compliance. And I don't know if you've looked at the CNCF landscape iChart lately, dear listeners, but there's a lot going on in this cloud native world. And today we're going to do a deep dive into an exciting and I think often misunderstood niche of service mesh. And let's start by the broader question, what is service mesh? These are words, we're sticking them together. We're saying they mean something. What is a service mesh?
Yeah, Delyan, should I take this one?
Please, Michelle, go ahead.
So the proper definition, I think, is it's a dedicated layer of infrastructure that helps you manage, secure, and observe service-to-service communication. So that's the definition you'll read everywhere, and I feel like at first glance that doesn't really make a lot of sense to people who aren't super involved in the space. So I think kind of stepping back a little bit, the problem here is that there's application networking and application networking related concepts are a little bit harder now because we're in such highly dynamic environments where your IPs for your applications are changing. If you're in Kubernetes, your pod IPs might be changing just because pods come up and down and it's not that big of a deal. The system handles failures. And so things are always changing all the time, and that is normal now. And so networking requirements have to become a little more dynamic as well. And so there are things like traffic encryption, access control, so figuring out which service can talk to which service. Traffic shifting is often talked about when people talk about service mesh. So that's you moving traffic from one version of an application to another version. What else? Observability and metrics. People want to really see and understand what is going on between the traffic and communication between your different microservices. So all of these topics come into play when you're talking about a service mesh. And it's a piece of technology that helps you manage those application networking components and rules and requirements.
I love it. That's super thorough, Michelle. And because I happen to know that Delyan is networking focused, I'm wondering if, Delyan, you want to tell us, how does a service mesh actually work? How does a mesh work in terms of, if a service mesh were going to mesh, how does it even mesh? What is the actual technical possibilities there?
Very interesting. Maybe I will start with the question of why the heck do we even need a service mesh? And I like to look at it from the perspective of perhaps the CTO of organization who they want to augment, they want to add a bunch of services, but they have very few resources as in engineers. And so they want to, add, observability, and they want to improve security, and they want to figure out how to manage traffic. There we go, networking. How do you do that when your engineers are already extremely busy? Well, you bring in the service mesh, you launch the install command, and boom, you get all those extra features, this beautiful basket full of new features that you get for your system. But how we achieve that? Well, yes, because it's primarily focused on encrypting traffic and observing traffic flying between the various pods and payloads. We do that by actually intercepting the traffic and adding encryption to it or capturing to see who is talking to who. And it's interesting because in the past, we've done that. We've been doing it for decades. Twitter has Finagle, Netflix was using Hystrix, and Google has Stubby. But those are libraries that are very tightly coupled with the various languages that you use, whether it's Java or Go. If you're using a bit more obscure language, you'll struggle to use Hystrix, for instance. So in the networking world, we take a sidecar, a reverse proxy, and we bundle it with your payload, and we pipe all the traffic through it. And then this reverse proxy sidecar will then add all those incredible features, like we said, MTLS, observability, or traffic management, splitting the traffic between the various versions of your services, for instance. See, I answered a few questions at once, Bridget.
I love it, but I also have new questions now. This is what happens. Because you're talking about intercepting traffic, and so there might be people who will hear that and think, wait, service mesh is some sort of man-in-the-middle attack as a service? Like, how is this safe? Is it safe to use service mesh?
Michelle, is it safe to use a service mesh?
It's actually trying to prevent those man-in-the-middle attacks, actually. So a big thing that we hear a lot about is this requirement around MTLS, so mutual TLS, especially when related to enterprise environments and like government-related requirements. They'll often say, hey, we need to make sure that the traffic between your services is encrypted, everything looks good, people are talking, or the services are talking to each other that in a way where the rules have allowed them to, and nothing's doing anything wonky. And I guess a lot of people are familiar with TLS because we use it all the time, right? That's when your client or your browser, for example, reaches out to a web server or web service and tries to get information back from it. We use TLS there. So the client reaches out and it basically asks server to prove its identity. And that's great for generally everyone, but because especially in public facing environments like web services. But now we've more and more we've seen that people want to kind of restrict access between different services. So this is where MTLS comes in, mutual TLS. And that's when both the client and the server have to prove to each other that they are who they are. And it actually, this is a security requirement that's becoming more and more common. It's really nice when you don't have to handle all that in code, and you can throw like a sidecar next to your application that handles that kind of stuff for you, and your service mesh makes sure everybody, you know, has the proper identity attached to them. So is it secure? It's trying to enhance security, so I hope so. Delyan, you have anything to add in this?
Yeah, maybe I'll go back to describing how we compose this service mesh and try to prove that it is indeed secure. And I think there's the three main components of the service mesh that compose it. We start with the reverse proxy, which we add in your pod as a sidecar, or we add it onto your VM, so it augments that payload. And then there's a certificate, which is being used to encrypt, decrypt traffic between the various services. That's component number 2. And component number 3 is the control plane, which actually tells the sidecar, the reverse proxy, what to do and how to do it. And all those 3 components are actually open source. The reverse proxy, we can review the code, make sure that it's secure. And by using the certificate, which is within the sidecar as well, we can prove that traffic entering the sidecar proxy may look like a man-in-the-middle attack, but it's actually provable what that proxy is doing. And it's very transparent that everything the proxy is doing, it's encrypting traffic and denying traffic between the rest of the proxies. So I think it's easy to show that traffic that is flowing in and out of that sidecar is already encrypted, and it's only flowing to other east-west services that we have explicitly allowed or permitted with SMI, actually.
Ooh, now that you've just unpacked a whole bunch of stuff that I want to get to. So let's start with, you're mentioning east-west services, you're mentioning pods and VMs, and at this point we have to bring it back to Kubernetes. And I guess my question to you folks is, on the scale of hot dog to not hot dog, like how does service mesh relate to Kubernetes? Is it a subset? Is it a superset? Is it, you know, orthogonal? When people are trying to figure out, well, I think I need some Kubernetes, but do I also need some service mesh? How do you unpack that?
Yeah, I think you don't need a service mesh unless you need those things that we Delyan and I kind of talked about earlier. So definitely don't feel like you need it. It's for a very specific requirements for a very specific type of environment. But the idea here is that, you know, it's really great for when you have lots of microservices running in your environment. Think like Twitter, think Lyft, you know, lots of different application components like talking to each other, and lots of specialized teams working on different applications that end up talking to each other to make this really awesome system work, really awesome application work. So so that's the kind of environment that you want to maybe have the service mesh put on. But those kinds of environments have been enabled by the rise of Kubernetes, the rise of containers, Docker, etc. So definitely not totally partnered up, but the service mesh the pattern has been enabled by Kubernetes, which has enabled highly dynamic microservice environments for sure.
You know, one thing that I keep hearing in conversations with various partner companies is always the concern that this great ecosystem that Kubernetes unlocks so much potential that at some point operators get lost in the complexity of it. And so how do you rein in that complexity? How do you make sure that only service A can talk to service B, between namespaces, or perhaps you have various teams in various namespaces within Kubernetes, but you don't want to necessarily allow every service in every namespace to talk to every other service in every other namespace. And so then you use a service mesh to control that east-west flow within the Kubernetes cluster. And then we also keep hearing about zero trust networking. Maybe all the teams operating in the same Kubernetes cluster don't necessarily trust each other for various reasons. And actually, one more thing strikes me as the most interesting. We keep hearing about auditability. An operator of a Kubernetes cluster has a very successful operation. Everybody's really happy, but at some point you lose track of what services even exist and who is talking to who. How do you actually map that out to understand what is happening? And I think Service Mesh is a really easy solution to all those basket of problems.
I'm laughing at the word easy because it's like, well, at least it's definable, right? And so this kind of brings me to the let's look at some. You mentioned SMI, but when people are saying service mesh, they start mentioning different planes, and it's a bird, it's a plane, like control plane, data plane. What are these planes of existence that we have to be living on?
I'll take a stab at this one. The by the way, east-west traffic, we kind of like mentioned that a lot. East-west traffic is like your services communicating with each other. And then when we say north-south, that's maybe some external traffic coming to your cluster and communicating within with services that are a part of your mesh. But a lot of times you'll hear east-west, north-south. When we talk about service mesh, you'll hear about data plane versus control plane. I think data plane generically just means the part of the network that carries user traffic. And so we've been talking about the sidecar approach to service mesh. By the way, sidecar approach is not the only way you can do service mesh. There are other meshes out there that do, proxy per node rather than proxy per app instance. But we've gone with we generally see service meshes implementing the sidecar approach. So the sidecars, all the proxies, that set of proxies is what we are referred to as the data plane. And then the control plane is the thing that is your source of truth for all your configuration. It bootstraps and manages those proxies. It manages their certificates. Delyan, anything else I'm missing here?
You're exactly right. I think perhaps from a service mesh developer perspective, the difference becomes quite drastic, because the data plane is something that needs to be operational 24/7 nonstop with as little latency as possible, because that's where all the data is flowing through, that is customers' data. And the control plane, of course, it also needs to be up all the time and be very reliable. But the control plane is, because it controls the reverse proxies, you have a little bit of flexibility around when you can upgrade it and downtime, etc., because the customer's traffic is not flowing through the control plane, it's flowing through the proxies that we call data plane.
Okay, and then you also mentioned SMI, and that kind of brings us to what's the difference between SMI and, say, a control plane?
Michelle, take it away. We have the SMI creator.
So SMI stands for Service Mesh Interface. It's essentially, we got together with a bunch of service mesh providers and created this portable set of APIs that represent the most common functionality that people want from a service mesh. So there's a lot of meshes, they all have their own like APIs and their own constructs. So this interface allows people who are actually building tools on top of service mesh technology to build against a consistent set of APIs without having to worry about what the actual implementation is, what service mesh provider they're using. So that's what it is at a high level. How does it differ from a control plane? Delyan, I'm going to pop it back to you for that.
Oh, that's a tough question. You know, SMI reminds me of kind of this pseudo language that we created way back in the day in college. A few people from a few different Eastern European countries that perhaps share the roots of a language, and we came up with like our own language. And I think SMI seems to me like the lingua franca of service meshes. And people oftentimes ask me, what's the benefit? And I think there's incredible benefit. You can install Service Mesh A and check it out, configure all your policies. Then you might decide, hey, what if I check out Service Mesh B? I want to see how that works. You don't have to change all your policies. SMI stays in your cluster. You swap the data plane. But how is SMI different than the control plane? Well, SMI is the language that defines, describes, creates the topology of your mesh. And then the control plane actually ingests all the SMI primitives and tells all the reverse proxies, or not reverse proxies, if you have proxy-less service mesh, it essentially from SMI to control plane to data plane on how to run the whole service. I hope this simplifies it a bit.
It at least gives people more breadcrumbs to go follow when they're learning about this. And so the reason that I had you two come on Arrested DevOps today is because you're announcing something today. And Michelle, you want to tell us what exactly, now that we gave people enough context to understand the announcement, what are we announcing?
All right, yeah. So Delyan is from the Azure networking side of Microsoft, and I'm from the Azure containers upstream team. So we contribute to upstream projects and do the open source thing. And we've actually come together and built out this project called Open Service Mesh. So this is a lightweight, Envoy-based, Kubernetes native, SMI compliant, all of the words that we've talked about today, service mesh. We've been working on this for several months now, and we're so excited to open it up and have people come and play with it.
It is so exciting to me. I think we've been working on that for a while. When I say we're first of all standing on the shoulders of giants. We've had people, like we said earlier, with all the libraries that were developed decades ago now. Then we had folks like Matt Klein come with this incredible proxy. We had, of course, SMI to unite all the various service meshes. And so now we're building this on standing on the shoulders of giants. But we have been focusing on a few guiding principles. Our goal here, our mission is to create, first of all, a service mesh and also source code that is very simple to understand and contribute to. And it's effortless to install, painless to troubleshoot. And of course, it's very easy to configure by using SMI.
Now I've got to roll it back just a little bit and say, oh, well, you're talking about proxies, and people maybe be like, okay, proxy, I understand that. You mentioned Matt Klein, who of course is famous for Envoy, and like, what are all those things again? For our listeners who are like, we don't even remember which all these things are. What are those things?
There's a lot of history in this space. It's been changing and evolving a lot, and it's gotten really it's a hot place to be. It's an exciting place to be. And so I think these people and these technologies are very well known within the service mesh community, with of course Matt Klein being the creator of Envoy. Linkerd2 is another SMI compliance service mesh, and they've been very active in the SMI community. Great folks to work with on that. What other terms were there that you threw out?
Oh, it's so hard to, I mean, there's so many different things. Maybe a good one to point out is we were getting into talking about standards and standards compliance. And why is that important? I mean, if we have a lot of service meshes and they all comply to a standard, do we have too many too many service meshes? What is even the point of another service mesh? So kind of like diving into the differences or the details.
Yeah. Well, I think, like, again, it's very early days for service mesh. So there are a lot of different opinions on what the control plane should look like, how it should scale, what the sidecar proxy should be, and which one would you use for different things that you need to do. How do you do ingress? Things like, what is the user experience like? What is the set of APIs you comply with? Things like that. So I think in terms of OSM, what we really tried to focus on is getting the project to a point where people can use kind of the most common functionality that people have been requesting. So we've implemented SMI APIs, and SMI represents that the most common features that people want from service mesh, which is MTLS, traffic shifting, access control, and metrics. Those are by far, we've done lots of surveying, talking to customers, working with other mesh providers, and we came together with this common set of things that we want to implement. So that's first and foremost things, that's something we're passionate about sticking with and making sure that this remains an SMI compliant piece of technology. And then we also are excited about kind of contributing back to the SMI community based on our learnings. So SMI is not just like, we developed a spec first and then we're developing the technology after. It's really, it was mesh first, lots of implementations came first, and then we got together and we're like, okay, we're gonna drive the spec, the interface based off of those learnings. So now that we have our own implementation here, we hope to, contribute back to the SMI community with those. Another thing that is a differentiator is that there are, lots of proxies to choose from to be in your, to serve as your sidecar. And we went with Envoy based. So we're very excited about all of the features that Envoy has. There's a lot of community momentum around this project. And we're just very excited to be involved with that community. We've been in touch with that community. They also have a really great way to write extensions with WebAssemblies. So it's, not only is it, production ready, hardened, proven, but it also is extensible, and that's like very important for us. And then we're also, although we're committed to like making things easy, so making things SMI compliant, we're also very committed to this no cliffs design philosophy that we have here at Microsoft. So, the idea is your project, your software should be flexible enough to handle both the simple scenarios as well as the complex scenarios. So, we're going to continue focusing on making sure everything's easy to use with SMI, but also we're going to focus on if you need to break out of SMI or if you need to do some really complex stuff, we're going to make sure that there is a path forward with that. There's a lot of talking. Hope that.
Oh, no, that's wonderful. There's a lot there. I want to focus in on this no cliffs thing. And I'm smiling. I started smiling when you said that because for anyone who's watching the video, Delyan has a picture of some cliffs behind him. So.
Oh, nice.
So
they're pretty steep.
Right. So I would actually like Delyan to kind of give us a little bit more depth on the idea of where do we move from simple to complex? What do those scenarios look like? And what are some of, I know nothing is set in stone, but what are some of the ways that those problems can be solved?
Yeah, very interesting. Well, maybe I'll roll back just a little bit. And one way that I think about the various service meshes before we jump into the no cliffs pattern, I think of service meshes as motorcycles. The various different service meshes that you have on your cluster are kind of like the motorcycles in my garage. They're all different, very, very different. You may have some, old school motorcycle that you really love for certain reasons, or something more modern that you like to work on. Some of them are simple to work on. Some of them are impossible. And I think that's why there's always room for one more service mesh or one more motorcycle, because they're all different and fine-tuned for various use cases. But
wait, do any of your motorcycles have sidecars? The important question.
Oh, you know what? I have not installed a sidecar on my motorcycle
Trinity.
Yet.
But anyway, back to the no cliffs.
No cliffs, yes. So one thing that we know with SMI, for instance, is that it doesn't obviously contain all the features that you might want to program on the proxy, like Linkerd or Envoy. We are launching OSM with Envoy as the default proxy right now. And Envoy is incredible with so many different features. One thing that you might notice in our repo is that we have put in a little bit of work to work on back pressure or circuit breaking, and that's obviously not part of SMI yet. And so that's one cliff, for instance. We think of that as a cliff. You perhaps develop the topology of your mesh and you create all the policies, but you want to do something that's not quite there in SMI. How do you do that? So to avoid that cliff, to avoid kind of the end of the road, we do have a continuation of the road. It's just not the smooth asphalt road. It might be a dirt road, but it does exist. And so you switch into maybe hard mode, and you might want to use XDS now, which is the Envoy protocol or the Envoy way of configuring things, which is much more difficult than SMI, but there is a way to now switch to XDS and fine tune all the Envoy proxies so you do get the benefits of circuit breaking, which Envoy ships with.
Wow, I mean, this is like, it gives our listeners a lot of things that they can go read and learn about. And so I would kind of ask, like, what do you recommend? Today we are on publication date of this podcast. We are also open sourcing all this. Where would people go to learn more about OSM, open source mesh specifically, and then this whole ecosystem?
Yeah, a great place to get started is on our GitHub repository. We have a great install and getting started guide. So we hope that you'll, run the demo and read the docs. We've tried to make it as painless as possible. So you're not going to be reading a ton of like a wall of text, but there's definitely a lot of information there for anybody to get started and just play with it. You can even have a local cluster like Kubernetes, Kind, or Minikube running, and you can like get started there. And if you have any if you read a doc and there's a spelling mistake or some grammar could be better or anything like that, if you want to add a test to the repo, if you're excited to even contribute to it, then please feel free. We have all the documentation on how to contribute on the repo as well, and how to build the project and things like that. So everything and anything helps, and we love feedback in the form of GitHub issues or join our Slack channel, all of that.
That is such a good point, Michelle. You just brought up something that made me like, oh, I got to highlight that. You brought up the idea of contributing to a project you don't know something about. And I find one of the most useful things is when people try the walkthrough and then they put in an issue saying, there's a leap of logic here.
Yeah,
what is happening? Because this doesn't work for me. And that's so helpful because maybe everyone who wrote that walkthrough had such and such already configured. They had Kind already set up or whatever. And so somebody goes in and they follow the steps in there, and it doesn't say, get your Docker daemon going. Yeah. And so people are like, this doesn't work. Well, it doesn't work unless we add in a little bit more context that only the newbie superpower of has never done this before can actually give that feedback. People working on the project cannot do it.
Absolutely. 100% agree.
One of the principles of this project has been, let's make the code as readable as possible. So I also hope that folks would come to the repo and, take some joy, kind of enjoy reading the code. And if it's not enjoyable, please tweak it, help us rename variables, reformat, make it yours as well.
Yeah.
That's fantastic. I love it. So we're almost out of time here. So let's just wrap by having each of you tell us, where can our audience follow your work or learn more about anything, motorcycles or anything else that you are really interested in? What would you recommend people would check out?
I'm pretty active on Twitter. At Michelle Noorali on Twitter, just my first and last name. My GitHub repo has a lot of random repositories in it, but I was really active or have been really active with the Helm project. And so I have a lot of random charts and apps. So if you're looking for examples for things like that, happy to, provide those and answer questions on that kind of stuff. So yeah, reach out.
Same here. Find me on Twitter at Delyan Raychev, and also on GitHub at draychev. My email is there. Shoot me an email. Would love to help you onboard to the repo, answer any questions about service meshes, proxies, SMI, Golang, you name it. Get in touch.
Awesome. All right. So head over to arresteddevops.com/service-mesh for this episode's show notes. We'll have links to all the repos and things people mentioned. Visit arresteddevops.com/iTunes and leave us a review in the iTunes store if you want to help other people find the podcast. I have no idea how that works, but apparently that is a thing that exists in the world. We're also on Spotify and iHeartRadio if you're into those systems as well. Thank you so much, Delyan and Michelle, for joining today.
Thank you, Bridget. Thank you, Michelle.
I'm Bridget at Bridget Crumhub. This is Arrested DevOps. And remember, there's always DevOps in the banana stand.